Find the lateral surface area, total surface area, and volume of this cone. Well, this is going to be pretty straightforward. The lateral surface area is pi RH, or no, pi RS, sorry. Just pulling that from the formula sheet. So pi times the radius. We're actually not given the radius exactly here. We're given the diameter of this particular cone. So what I'm going to do is I'm going to take and divide that by 2 to get the radius. 15.8 divided by 2 gives me 7.9 centimeters, and that's what I'm going to be using for all my formulas. So 7.9. My slant height was this distance here. It's the distance along the edge, as opposed to this one, which is measured at a perpendicular to the base. That's the height. This would be the slant height. This is the one we're looking for right now. Times 17.4. So pi times 7.9 times 17.4 gives me 431.84. Given that everything here is actually rounded to 3 significant digits, I think it's reasonable to round this one to 3 significant digits. Call it 342 square centimeters. The total surface area, which I'll call S, which is going to be our lateral surface area plus the surface area of the one base that we have. The base is, of course, a circle, 7.9 centimeters. The area of this circle is pi r squared. So pi times 7.9 squared, which gives me 196.06.07. So, adding these together, 432 plus 196. 432 plus 196. This is going to be rounded. If I'm rounding this one to 3 significant digits and that one to 3 significant digits, the 0.07 is going to go away. I end up with 628 square centimeters. And then for my volume, this is 1/3 times the area of the base times the height, except the area of the base is pi r squared. Actually, I guess we already have it. I have it over here, 196.07. Times the height, which is 15.5. So this gives me 1 divided by 3 times 196.07 times 15.5. Rounding this to 3 significant digits as well, since the other ones are, that's 101, or 1010 rather, cubic centimeters. So I'm going to say round to 3 significant digits. Find the weight of the cast iron shape shown. Round to the nearest pound, and then they give us the density of iron in pounds per cubic inch. Looks like everything in this problem is given in inches, so if I find the volume, it's going to be in cubic inches, so that's going to be pretty handy right there. Alright, so as far as actually finding the volume of this thing, this will be the volume of the cone. There's a cone on the top here. Actually, I don't know why we're at vol cone. I should do V total is equal to V cone plus the V cylinder. So V cone, the volume of the cone that's on the top there is going to be 1/3 times the area times the height. 1/3 times the area times the height. The radius of this particular thing, so if I was to kind of look at this as a cylinder and a cone a little bit more like that, you can see this 10 inches down here is the diameter, so actually 5 inches is the radius. That's the number I'm actually looking for here. So when I go to do 1/3 pi r squared, it'll be 1/3 times pi r squared h, 1/3 pi times 5 squared times the height, which is 6 inches. Again, I'm talking about the cone right here, so even though I'm using the measurement down here, that's the same as the measurement up here, because that's a cylinder. It's the same throughout it. So that means that my radius here was 5 inches, my height is 6 inches, which gives me 1/3 times pi times 25, that's 5 squared, times 6 is 157.08. volume of the cylinder is, so I'm just doing some extra accuracy, some extra digits here. I'm going to be rounding this thing eventually to the nearest pound. If I end up having more than 4 decimal places of accuracy necessary, I could always go back and fix this. So I might actually show that I rounded here by doing an approximately equals. If I need to come back and fix things, I can add more accuracy on at that point, but I'm pretty sure 5 decimal places is going to be more than enough. If I'm rounding it to the nearest pound, I don't expect this weight to be more than 15,000 pounds. Or, you know, more than 10,000 pounds, I guess. All right, in any case, volume of the cylinder is, this is going to be the area times the height. So no 1/3 on that, it's just the area of the base times the height. Again, pulling that from our the formula sheet. So this would be pi r squared times the height, except this is not the height of the cone, this is the height of the cylinder, which is 13 in this case. I should probably move that down here. This should be pi r squared times height, which is pi times 5 squared times 13, which gives me approximately pi times 25 times 13 gives me 1021.08, 0.01 rather, 02. Yeah, whatever. I'm doing more accuracy than necessary again. Alright, so the volume total, adding those together, gives me 1178.10, I guess. Yeah, 1178.10. And this would be cubic inches. But of course I want this to be in pounds, so this is 1 pound per 1 cubic inch, or per, it's not 1 pound, it's 0.26 pounds per 1 cubic inch. So the cubic inches cancel, means I'm going to take this number times 0.26, which gives me 306. I'm rounding to the nearest pound here, which we'll call just 306 pounds. So that's a pretty heavy little trinket there. Of course, 10 inches across, 13 inches high of pure iron. Yeah, you would expect that to be pretty heavy. The reason you would want to do this, the reason you would want to figure out how much this would weigh before having the physical item there is, let's say you're making this, when you're making it from, well, from iron, you want to know how much iron you need to melt down to make this thing. If you have only 200 pounds of iron and you start melting it and start making it, it'll only go up to about here, and you'll have to remelt that whole mass again when you go to create this whole thing, because chances are it wouldn't bond correctly if you didn't kind of do it all in one pouring. So it's very handy to know the approximate weight of something before you actually go and pour it. So this would be approximately 306 pounds, and you know how much weight, how much material, raw material you need when you go to make it.